Hello everyone. It's gonna be a short one today, but we got us a science stream. We got a couple stories to share with you. So let's get on into it. So this first one is talking about a toxic gas that could spawn life. It's been found on Enceladus. I actually didn't look up the pronunciation of the moon beforehand. And let me take care of the Steam as well. No notifications. None at all. Okay. So, let's see. Enceladus, the wintry moon of Saturn, is a gift that keeps on giving for those that are delighted by the possibility of alien life. Heat compounds that could support alien microbes or help life emerge have been detected in the enormous plume of water that erupts from vents in Enceladus' icy shell by physicist Jonah Peter of Harvard University, reported December 15th, the American Geophysical Union annual meeting. These include hydrogen cyanide, which can be toxic to humans, though Peter noted it's also a key building block for synthesizing more complex compounds, including amino acids, sugars, and nucleobases, which in turn are precursors for proteins, RNA, and DNA. So the findings are good tidings for the. Let me see. What is the? Is this just? Isn't it just carbon, nitrogen, hydrogen? Let me double check. Yeah, this is all hydrogen cyanide is. Just one carbon, one nitrogen, one hydrogen. Which, fair. They could be key building blocks. Let's see. Findings are good tidings for the NEST team developing the Exobiology Extant Life Surveyor, or EELS, a snake-like robot that can one day crawl into Enceladus' frozen crust to seek out signs of life in the ocean below. Though that ocean has never been directly observed, it is thought to be the source of the huge water plume spouting from Enceladus' south pole. I see this water plume spraying water nearly 10,000 kilometers into space. And well, I guess if it breaks the atmosphere, then it will just keep going. See, false color image, James Webb. Let's see. Researchers have previously reported that the plume contains phosphorus in the form of phosphate, establishing Enceladus as the first alien ocean world known to possess all the elements essential for life. I do remember a lot of talk of Enceladus being one of the moons that, or was it Enceladus? I thought it was another moon, another ocean moon. Hello, Riven. It's going well. It's going well. Talking about the possibility of life in our solar system, maybe possibly, or at least the right components for it. Now, I wonder how Enceladus is for oxygen. Let's see, detection of phosphorus bolstered the moon as a prime candidate for hosting extraterrestrial life, and the new findings from Peter's team offer even more support. Let's see, with hydrogen cyanide and phosphate, Enceladus might be seen as a favorable prebiotic system, or a chemical setting capable of giving rise to life, said Christopher Glein, a geochemist at the Southwest Research Institute in San Antonio, who's not involved in the study. Peter and colleagues conducted a detailed analysis of data collected by NASA's Cassini probe as it flew through Enceladus' plume in 2011-2012. Okay, so this thing is pluming all the time. In addition to hydrogen cyanide, the spray contains acetylene, ethane, and various alcohols. The team also reported December 14th in Nature Astronomy. Oh my god, that's loud. Okay, maybe it's not as loud as I think it is. Still gonna turn it down slightly. Oop. Let's see. So these compounds fuel some microbes on Earth, Peter said, and could supply large amounts of metabolic energy for any potential life on Enceladus. See, though NASA had no mission scheduled for Enceladus, habitability has already spurred the development of eels. A 100-kilogram, 4-meter-long robot consists of ridged cylindrical segments. These pieces can be angled and rotated in different ways to make eels slither, sidewind, or move vertically inside crevices. So this is, I guess, the robot they're wanting to put onto the moons to be able to go through everything. See, eels were over here over some snow at the Big Bear Mountain Resort in Southern California during a field test February last year. Robot's most recent field test occurred in September on the Athabasca Glacier in Alberta, Canada, reported technologist Masahiro Ono on December 13th at the meeting. On the glacier, Ono of the Jet Propulsion Laboratory in Pasadena, California, and his colleagues tested the vertical mobility of eels inside 3 ice shafts or moonlands. The robot first succeeded at holding itself steady in the moonlands, unfurling its body to lodge itself between the frozen walls. Then, by carefully rotating treaded rings on its body, eels safely completed multiple 1.5-meter descents. Only 1.5 meters though. How deep is the ice on Enceladus? Let's see. Let's look up the moon. Let's see, small icy body, ice depth. 5 kilometers at more than 30 kilometers. It's quite a bit of ice to get through for a little thing like that. Let's see, following further tests on the glacier, the next stop for eels might be Earth's moon. For instance, a small version of Space Snake could be deployed to assist stationary lunar landers. And I said this robot's game changer, he said, and not just for Enceladus. Well, we wish the little robot good luck in its field tests, and we'll continue as we have for the past probably centuries to see if any life sprouts up from in our solar system. Once it loads. Next story we're talking about, Nanotyrannus versus T-Rex Hog continues. Controversial study doesn't settle the question at all. New study of long debated dinosaur fossils found growth patterns inconsistent with those of T-Rex, suggesting the bones belong to a distinct species, but other experts aren't convinced. So basically, just the classic, classic like, these bones kind of look different, but we're not quite sure. Let me just change this. T-Rex or not. And let me respond to an email super fast. So let's see. In the latest episode of a long-standing debate over the identity of a set of dinosaur fossils, a controversial new study has found that the dino bones belong not to a young Tyrannosaurus rex, but to a separate species, Nanotyrannus lancensis. Let me look at this little guy. So just, I'm guessing like a little teeny tiny T-Rex-like creature. Let's see if we can find a comparison. So not a lot of discussion about it, I suppose. Let's see, in the decade since the first skull was discovered in Montana in 1942, paleontologists have gone back and forth on whether the skull and later fossil discoveries belong to a distinct species or to juvenile T-Rexes. Ah, that's the argument, whether they're little baby T-Rexes or not. Authors of the new study published Wednesday in the Journal of Fossil Fossil studies claim to have snuffed out the baby T-Rex hypothesis once and for all, although other experts aren't convinced. That's the thing, even if you put out a paper, unfortunately, it still might not be enough to convince everyone. I'd say I was very skeptical about Neotyrannus myself until about 6 years ago when I took a close look at the fossils and surprised to realize we'd gotten it wrong all these years. Lead author Nicholas Longrich, paleontologist and senior lecturer at the University of Bath in UK, said in a statement. When I saw these results, I was pretty blown away. Longrich and co-author Evan Seda, a paleontologist at the University of Chicago and research associate at Chicago's Field Museum of Natural History, measured growth rings in the fossils and found they were closely packed towards the outside of the bone. This pattern is inconsistent with the rapid growth of a young dinosaur and suggests growth was slowing and the dinosaur was reaching its full size when it died. See, if they were young T-Rex, they should be growing like crazy, putting on hundreds of kilograms a year, Longrich said. When the researchers modeled the growth of the fossils, they found that the dinosaur would have reached just 15% the size of a mature T-Rex, weighing around 2,000 to 3,300 pounds. I wonder if, I guess I also wonder how much of dwarfism occurred in dinosaurs and whatnot. If that could be anything. So let's see, weighing around 2,300 pounds, measuring 16 feet long, or 5 meters. In comparison, adult T-Rex is about 17,600 pounds, 8,000 kilograms, and stretched 30 feet, 9 meters in length. I mean, I guess this mouth is kind of closed, but they are. Let's see. Skull of an adult Tyrannosaurus rex compared to a skull thought by some paleontologists to belong to a distinct species. I mean, kind of looking at some things, I guess if, in theory, if this was like a baby T-Rex skull, there could be some, you know, some things that would be, like, the shape of the skull could change a little bit. Sort of like in humans, how babies actually have much more fragments of their skull and they fuse together as they get older. But I feel like I could fully believe it being a different species. See, I mean, I guess the big evidence would be like, okay, well, like, where are some baby T-Rex skulls that we can compare this to? Let's see, researchers also reconstructed the dinosaur's anatomy and found it shared no distinct features with an adult T-Rex, which it likely would have done if it was a young T-Rex. In the same way that kittens look like cats and puppies look like dogs, Longrich said. Could be growing in a way that's completely unlike any other Tyrannosaur or any dinosaur, but it's more likely it's just not a T-Rex. The reconstruction also didn't match other fossils of a young T-Rex that did share features with adult T-Rexes, the researchers said. Okay, so there you go. Unlike T-Rex, the dinosaur had a light build, long limbs, and large arms that would have been pretty formidable weapons, Longrich said. It's really just a completely different animal, he added. Other experts aren't backing the idea that the fossils belong to Neotyrannus. The article doesn't settle the question at all, Thomas Carr, vertebrate paleontologist and associate professor of biology at Carthage College in Wisconsin, told Live Science in an email. The authors don't seem to have a solid grasp on growth variation in Tyrannosaurs. So, basically, this guy is just like, hey, listen, Tyrannosaurs go through a lot of different growth variation. Which, I don't know, I feel like there is growth variation through development of different species, but a lot of times species also are pretty distinct and specific in their, in how they grow and whatnot. I don't know. Let's see, in 2020, Carr found more than 1,800 differences between juvenile and adult T-Rexes, considerably more than the over 150 differences emphasized in the new study, he said. We should expect that magnitude differences between juvenile and adults, he said. Or he added. Okay, so he has, I guess, gone over a lot of different juvenile and adult T-Rex skulls, or bones in general. Let's see, young juvenile T-Rex frontal skull bone from the Hell Creek of Montana. This is a teeny little piece. Opponents to the Nano-Tyrannosaurus theory says the skull of these dinosaurs have unique features only seen in T-Rex, including a wide forehead and narrow snout. Thomas Holtz, a principal lecturer in vertebrate paleontology at the University of Maryland, is also skeptical. Ultimately, the key fossils needed to sell this fully adult Nano-Tyrannosaurus that are not Tyrannosaurus, or 11 to 13-year-old Tyrannosaurus that are definitely not Nano-Tyrannosaurus, or Nano-Tyrannus. Haven't been discovered, he told Life Science in an email. So... yeah, I guess that would be a good point of needing to find some adult Nano-Tyrannus. So the saga continues, said David Hone, a paleontologist and reader in zoology at Queen Mary University of London. There's a bunch of old ideas resurfacing in the new study that weren't any more convincing than they were before. And there's some new ideas which mostly aren't very convincing either, Hone said, or Hone told Life Science in an email. Currently, only T-Rex is recognized in the Tyrannosaurus gene. But Hone suggested Nano-Tyrannus or another set of fossils could prove to be a second closely related species in the genus. He and other paleontologists are happy with the idea that there might be more than one species, Hone said. It's odd in some ways that Tyrannosaurus is apparently a uniquely large predator in its ecosystem, he said. Discovery of a second species in the genus might fill some gaps and explain away some inconsistencies, he added. That was always going to have to be with some really convincing arguments that overturn a lot of ideas and data that people have been building for years, even decades. So, basically, more or less, it would be cool if we had... I'm curious what this little structure is here. I'm guessing that just holds the brain in place in the skull. Brain/eyes. Eyes here or eyes there? I think they're here. Okay, I don't know. I'm curious. I wonder where this Nano-Tyrannus theory started. Oh right, it said 1942. Let's see, pygmy or dwarf tyrant. There's a broad back, boxy back of the skull. Let's take a look at this little... I also like this little bump they have. Oh wait, is this one... Is this literally a picture of that one? It might be the same skull. No, it might be slightly different. But it does look similar. Let's see, and this came out in 2020, so I'm guessing this was about when... maybe around when Carr was talking about differences between the two. Well, I guess the battle that we never knew was happening continues to rage on between the possibility of a Nano-Tyrannus and it just being baby T-Rex. So now, move on to something I found about recently that's a little concerning. But, geologists say plastic rocks are now a thing. And that's kind of worrying. So, plastic is now a geological phenomenon. I don't remember if it says it here, but I remember reading that humans have literally made their place in the geological, like, how do I say it? In like, this geological era, when people look back, or, you know, aliens or whatever, look back at the geology, they'll find layers of plastic to be like, this is when the humans were, because there's just so much. So, sedimentary rocks make up around 75% of the rocks on the planet's surface. They're also the type of rock that interacts most with surface processes like water movement, erosion, and, as it turns out, pollution. In recent years, geologists have been finding more and more plastic rocks in various shapes and forms. There's plastaglomerate, plastitar, and plasticrust, but no unifying definition for them all until now. In this context, we propose the adoption of an existing term, plastistone, with a revised definition to collectively describe these novel plastic forms. Luwei Wang and Dai Ho from Tsinghua University. Plastic geology, how are plastistones formed? Unlike traditional sedimentary rocks like limestone or sandstone, plastistone is a hybrid natural rock and synthetic plastic. This combination occurs when plastic waste becomes intertwined with natural rock elements, leading to unique geological formation. The process of lithification, which turns loose sediment into solid rock, is at play here, incorporating plastic as part of the rock matrix. Also curious if we can get, I was gonna say, like, plastic fossils, but I guess if plastic isn't really degrading or withering away, then it wouldn't exactly make a fossil out of it. Plastistones have been found on a global scale, both in coastal and inland regions, the two researchers say. They formed through the fusion of natural rock and plastic waste, a startling indicator of human impact on the planet. Formation of plastistone can occur through various mechanisms. One common method is through the melting of plastic debris in environments like campfires or waste burning sites. Melted plastic then adheres to existing rocks or sediments, eventually cooling down and solidifying into a rock-like structure. The resulting plastistone can exhibit a variety of appearances depending on the types of plastic and natural rock involved. So basically getting attached to a rock and then that rock getting buried. And yeah, you just have this layer here of rocks that begin to have plastic. Which, God, can you imagine the conspiracy theories there of future generations being like, it doesn't make sense that there be plastic in the ground or whatever. So it's the emergence of surrounding sediment, create a composition. The emergence of this new layer is being used as physical evidence of a marker horizon for an Anthropocene epoch. I think that's the right word I was looking for, epoch. Let's see, so what's in the plastistone? Common plastic types found in plastistones include polyethylene, terephthalate, and polypropylene. These are often sourced from domestic waste such as packaging, containers, or maritime activities. The physical properties of plastistones can vary significantly, influenced by factors like the amount and type of plastic involved, the nature of the surrounding rock or sediment, and the specific environmental condition during formation. However, there's a good chance that there's plenty more types of plastistones out there that we just haven't discovered yet. Oh yeah, so there's all the, I'm guessing, like, fishing net and whatnot. Let's see, a plastic rock found in Hawaii in 2014. Yeah, so we basically just have legitimate plastic rocks now that are out and about in the world. And, yeah, it didn't surprise me. A lot of a huge amount of plastic waste is due to, like, fishing boats and whatnot out there, just dumping a lot of material. Plastistones have been shown to alter the microbial communities of the surrounding environment and can generate significant amounts of microplastics and nanoplastics. Potential for these rocks to release microplastics and nanoplastics into surrounding areas raises concerns about their long-term ecological effects. Plastaglomerate poses an imminent danger to ocean sustainability, blue economy, and overall human health, Ho told Newsweek. In fact, the interest around these rocks is more environmental than geological. Yet another sign of the Anthropocene, which I think is basically the word for our era. Yeah, the current geological age. Which, granted, I don't know as much about geology. Yeah, so Paleozoic, Mesozoic, Cenozoic. Then here we are. So this new type of sedimentary rock provides compelling evidence of how human activities can act as a powerful exogenic geological process that reshapes the geological record of our planet. There's a lot of talk about the Anthropocene, the new geological era that mankind has ushered in on Earth, and plastistones are a good example of that. The world produces a whopping 380 million metric tons of plastic annually, damn, and a large part of that plastic ends up in the world's oceans and rivers. We're producing so much plastic, we're changing the planet's geology, and plastistones, as an emerging type of sedimentary rock, symbolize the profound and lasting impact that humans have. The study of plastistone is still in its early stages, and much remains to be understood about its formation, distribution, and impact. Future research will likely focus on mapping the global distribution of plastistone, understanding its various formation processes, and assessing its ecological and environmental implications. Monitoring the evolution and spread of plastistone, it will be crucial in understanding the broader effects of plastic pollution on the planet's geology. Yeah, and, unfortunately, this isn't even a thing I can just be like, oh, recycle or whatever. Because unfortunately, it's not, it's not, a large, like I said, a large amount of this plastic is from, like, fishing and whatnot. So, unless you're a fisher working on a huge fishing boat, I don't think there's really too much I can say as far as, I guess just don't melt your plastic and throw it on some rocks. That's the best I got. So for this story, NASA's set to touch the sun in 2024, a milestone for space exploration. So I think this is, basically saying that they're gonna put a satellite that comes in very, very close contact with the sun in the near future. So let's see, NASA's Parker Solar Probe is set to pass the sun this year in a milestone moment for space exploration. The probe, launched on August 12th, 2018, is due to fly past the sun at 195 kilometers per second, 435,000 miles per hour on 24th December 2024. Damn, fast. Launch that thing out of here. NASA describes it as a mission to touch the sun on its website, aiming to get our first ever sampling of a star's atmosphere. We're basically almost landing on a star, Noor Raufi, a scientist on the project, told the BBC. This will be a monumental achievement for all humanity. This is equivalent to the moon landing in 1969, he said. Big claims. The mission aims to help us gain a deeper understanding of the sun, with the probe orbiting closer to the sun's surface than any as before and within Mercury's orbit. I'm curious of the... Did it say how close it would get? So I'm curious on the composition of it and how close it'll actually get there. So let's see. Probe gathers measurements and images to help scientists learn more about where solar wind comes from and how it is evolving. It also makes critical contributions to forecasting changes in the space environment that affect life and technology on Earth. Probe will face extreme heat and radiation on its journey, flying more than 7 times closer to the sun than any spacecraft. Dr. Nikki Fox, NASA's head of science, told the BBC that they don't know what they'll find in the mission, but will be looking for waves in the solar wind associated with the heating. Suspect will sense lots of different types of waves, which will point to a mix of processes that people have been arguing over for years, she added. Okay, so basically they don't exactly say how close it's supposed to get, but it's gonna be zooming past. And, hopefully we'll get some information out of that. Well, I guess we'll check in on that in about a year and see how well that went. So for this last thing they have, this is actually more of just a very fun, silly little study that I found out about recently. And it basically talks about the dangers of not using a good sample size / just believing everything off of, say, one type of test. So let me get into that in a second. Okay, so basically, this came out in 2009. It was getting into how MRIs were used for so many studies to try to study the brain and try to say like, oh, this is where this, thought comes into the brain, or like thinking this has this effect on the brain. You might have heard the articles of like God is in the brain here, basically looking at religious people and non-religious people and being like, oh, see, religious people have this part of their brain light up more or whatever. So essentially, here we'll go through the methods and you'll get what I'm getting at here. So what they did was they took one mature Atlantic salmon that participated in the study. Salmon was 18 inches long, weighed 3.8 pounds, and was not alive at the time of scanning. So they took a dead fish and they subjected it to MRIs. So basically, what the task is, for the salmon involving completing an open-end mentalizing task, the salmon was shown, dead salmon by the way, was shown a series of photographs depicting human individuals and social situations with a specified emotional valence. Okay, so basically the salmon was shown people just, doing whatever and having a very specific emotion on their face. The dead salmon, was asked to determine what emotion the individual in the photo must have been experiencing. I very much do hope they fully committed to this. Which, they did take the MRI pictures, so. But they basically just said to this, they had this dead salmon laying there, and they're like, what emotion do you think this person has in this picture? And then they would just take an MRI picture of the salmon. So let's see. Each photo presented for 10 seconds, followed by 12 seconds of rest. Total 15 photos are displayed. Total scan time is 5.5 minutes. This is just getting to the details of how the MRIs were taken and the statistics that went into looking that they calculated from everything. So here are the results. So we got this dead salmon. And I'm very curious of like how long it was dead, but I guess it doesn't exactly matter. And they're saying that, with this one sample, they had a significant, difference in like this little spot or whatever in the brain region when showing these pictures. And same here. This is showing, the average image for all the voxel, all the images. This is showing the standard deviation values for each of the voxels. And then this shows the, basically it just shows like, here's all the sections that we found on the MRI that had different readings. So, they generate all this data from, again, I cannot emphasize this enough, this deceased salmon that they asked to identify human emotions. And, I don't know too much about fish, but I'm pretty sure even a live salmon couldn't do that. So basically what this takeaway is saying is we cannot fully just rely on MRIs to answer our questions. Because obviously there's a lot of statistical errors that can be picked up and a lot of false positives that can be picked up with MRIs. Unless we want to go with the other result of dead salmon can in fact read human emotions, and we should be looking at dead fish to figure out what else they know. So this was basically just a very small, kind of like spiteful study you know, as they say here, can we conclude from this data that the salmon is engaging in the perspective-taking task? Certainly not. Yeah, just saying it's random noise, and, you know, we need to have, trying to see, basically, yeah, need multiple comparisons, can't just use one subject to try and make these huge claims, and that we need to not rely as heavily on just the standard statistical thresholds in situations like this. And I love a study that's done more or less out of spite and just being like, hey, guess what? Hey, you're all stupid for doing your study like this. We did the same thing on a dead salmon. Look what we got. So yeah, this is just to remind you that science is not always infallible, because there are people behind these studies and they will just push whatever. In fact, I think I read something recently of I want to say at least, I think it was like maybe about 10 studies had to be pulled, and more than like 30 had to be corrected because they were all using data that they didn't actually get, or at least pictures that they didn't actually take themselves, and just a bunch of these studies had similar pictures. So yeah, unfortunately, even with the study, you kind of have to dig into it a little bit to be like, how legitimate is this? But that's just, unfortunately, that's just the field of needing to look through all the research and everything that goes into stuff. But yeah, that's, like I said, this is gonna be short. That's all I had. I really just didn't see a whole lot that I guess I felt like talking about. But I wanted to get these out at least. And you know, if anyone has any interesting scientific discussion topics that they want to have, you know, you can just send it to me, just DM it to me or whatever, and I'll take a look and maybe we'll talk about it. But alright, that'll be it for today. Hope everyone has a good rest of their day or night, and I'll see you next time. Hey Killer, of course, lurk away anytime. Alright, goodbye everyone.